I'm gonna go over like some review problems that are going to be similar to those on the exam. I'm not gonna give you time to try because it will take a lot of time to you to finish, if that makes sense. And let's start. So the first one is solving equations. Say we have 3x squared plus 7x minus 6 equals 0. How do we solve such equation? Well, if it's not equal 0, make sure it's quadratic. You set everything equal to 0. So what you do here is factor this one out. Factor this one out. And what goes here? 3x and x. It's called trial and error. And the 6 can be 6 by 1 or 3 by 2. So if you try like 3 here and 2 there, it's a negative, so one of them has to be negative, one positive. And then you test it out. If you multiply these, that's negative 3 and 6. Add them up. Oh, that doesn't give me the middle one. So then what you do, you swap the 2 and the 3 and test it again. Minus 2x, 9x. Oh, that gives me the middle one, so it worked out nice. So then for this to be equal to 0, the first factor has to equal 0, the second factor equals to 0. So that gives me x is 2/3, or x is negative 3. Another equation, x plus 1/2 square equals 49 over 4. How are we going to solve such equation? So now how do we solve such equation? Let me recall a property called the square root property. The square root property said if y squared equals a number m, then y is plus or minus the square root of m. Important property. So if I want to apply it to this example here, we got x plus 1/2 is plus or minus the square root of 49 over 4. And we know the square root of this is 7/2. But don't leave it like this. The plus or minus, it means two cases. One time it's a plus, one time it's a minus. So subtract 1/2 on both sides. You get x equals 6 over 2, which is 3. Subtract 1/2 on both sides. Negative 8 over 2, negative 4. Ta-da! More equations. 2 to the 2x minus 1 equals 1 over 16. What do we do for this? I'm going to rewrite the 1 over 16. You can prime factorize it. Prime factorize 16, 4, 4, 2, 2, 2, 2, prime, 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 prime. We have 4 copies of 2. Then keep the left hand side the same. Bring this up. And in order for this one to work out, the two bases are the same. So we can set the top equal to each other. Add 1 to both sides. Divide by 2. Number 4 log of x plus 5 minus log x minus 1 equals 2. How do we solve such equation? Well, we can review the properties of logs. It says log x over y, it's log x minus log y. Log x times y is log x plus log y. Log x to the m is m log x. Good to know, very important. So here, this looks like this one, but backwards, we can go backwards to make it one log. We can divide it. Notice there's no base here, automatically means base 10. And also, the main definition of log, it says log x base m is n, equivalent to say m to the n is x. So this means 10 to the second power is x plus 5 over x minus 1. Keep this the same. 100 over 1. Cross multiply 100 times x minus 1, 1 times x plus 5. Then distribute the 100 in, the 1 in, and solve. So we subtract x on both sides, add 100 to both sides, divide by 99. Notice both of them are divisible by 3. By 3 is 33, and by 3 is what? 3, 9, carry over 1, 15, 5. So 35 over 33. Another equation. We need to divide by 2. Yes, divide by 2. When we divide by 2, we get 4. And then, as Nikita said, L on both sides. That's the only way to bring this down to the front. What's ln e? Natural log of e is 1. So to solve for x, we divide both sides by -2. Then what is x? So if we are solving over the complex numbers, x would be plus or minus the square root of natural log of 4 over -2. One thing you can do with this, the 4 you can write it as 2 square. And the 2 square becomes 2 natural log of 2 over -2. The 2's cancel each other. So x equals plus or minus the square root of negative natural log of 2. This negative number, you can take it outside as an I, if you remember from complex. And natural log of 2 stays inside. another equation. So what do we do here? We need to do list the factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. We're using what we call the rational root theorem. And we are going to test these, see which one gives us 0. So let's test using syntactic division. 1, negative 2, negative 5, 6. Those are the coefficients. Let me try with 1 first. Bring the 1 down. Multiply. 1 times 1 is 1. You get negative 1. 1 times negative 1. 1 times negative 6. So that works right away. We are lucky. We are lucky. So that equation becomes x equals 1 works. So x minus 1 is a factor. And what is left in there? It depends on these coefficients, the ones that I'm highlighting. Those are, gives me 1x squared minus 1x minus 6. Then I can factor this one even further by doing x minus 3, x plus 2. And to finish solving this, you get x equals 1, positive 3, and negative 2. I'm going to write matrices problems. Let A equals 3, negative 3, negative 4, 5. B equals 4, 2, 1, 9. Find and simplify part A minus B, part B, A times B, C, the determinant of A, and D, B inverse. So A minus B, you take matrix A minus B. So the way you do this, 3 minus 4, negative 1. Negative 4 minus 9, negative 13. Negative 3 minus 1, negative 4. Negative 3 minus 2, negative 5. A times B. So A is 3, negative 3, negative 4, 5 times 4, 1, 9, 2. To multiply matrices, we multiply row by column. What is row by column? So 3 by 4, 12, and negative 4 by 1 is negative 4. So 12 minus 4 is 8. Row by column. 3 by 9, 27, and negative 4 by 2, minus 8. So that's 19. So I'm done with the first row. Next row. So now we do this row by the first column. What do we get? Negative 4 times, negative 3 times 4, negative 12, and 5 times 1, 5. That's negative 7. Same row by the next column. Negative 27 plus 10, negative 17. Determinant of A. How do you find determinant of A? So that's like we put an absolute value like that. the way to find determinant, all you have to do, multiply this by this minus this by this. So the answer is 3. Next one, B inverse. To find the B inverse is 1 over the determinant of B times the way to find the inverse. If you look at matrix B, we switch the entries here. 2 becomes 4, 4 becomes 2, so 2, 4. And the other entries here, we switch their signs. And what's the determinant of B? Well, let's see. 4 times 2, 8, minus 9, negative 1. This stays the same. That's a negative 1 times 2, negative 1, negative 9, 4. And as a final step or last step, we multiply everything by negative 1. You get negative 2, 1, 9, negative 4. That's another way. You can find the inverse using rewriting, taking the matrix B and then put 1 0 0 1 and then rewrite this as 1 0 0 1, and that would be the inverse here. But the one I just did is much easier and quicker. This way is much easier. Next problem I have in mind, solve system of equation 3x plus y. Let's say we have a 2 here. Let me find a good number here. Minus 2. And this. We can do elimination. Let's say I want to eliminate the y's. I multiply by negative 3 here. That gives me negative 9x minus 3y is negative 6. Keep the second equation the same. These cancel. So you get negative 8x is negative 8. X is 1. And then you can use the first equation. Substitute x1. 3 plus y is 2, y is negative 1. For this, let's say I want to eliminate the x, multiply by 3 here. Keep the first equation the same. Negative 3x plus 6y is 21. This, oh, both of them cancel. That's no way it's true. We say no solution. The system has no solution. Next system of equations. Let's say x plus y plus z equals 1. 3x minus y plus z is negative 2. Negative x plus 2y minus z equals 0. Even if the numbers are not nice, but at least the process what matters here. Yes, so what do? We group them. let's say I want to eliminate the z's. I take these together maybe and the last two together. So when I take the first two together, and in mind I want to eliminate the z. Whatever letter you decide to eliminate in the first two, you do the same thing for the last two. So decide on the z. Okay, I need to multiply by negative here. So that would give us negative x minus y minus z is negative 1. Keep this the same. These cancel, so you get 2x minus 2y is negative 3. This is the first one. The last two equations, again, you must eliminate the z's again. Not y's or x's because it's easier to eliminate them. We must eliminate the same variable, which is really the easiest here. So you get 2x plus y equals negative 2. Now we got two equations. 2x minus 2y is negative 3. 2x plus y is negative 2. These two boxed equations, you put it as a system like so. Let's say I want to eliminate the x's. So you multiply the top by negative. Negative 2x plus 2y equals 3. 2x plus y, negative 2. These cancel. 3y is 1. Y is 1/3. Now I need to find x and z. I can pick any of the equations. Y is 1/3. We don't like to see fractions. We multiply everything by 3. So 6x plus 1 is negative 6. Subtract 1 on both sides and divide everything by 6. I got y and x. We still need to find z. Maybe you can go back to the original equation. One of the x plus y plus z is 1. X is negative 7/6. Y was 1/3. We don't know about z. Is 1. We multiply everything by 6. That's the LCD to all of them. The 6 will kind of clean up the fractions. Negative 7 plus 2, plus 6z negative 5 plus 6z equals 6. Add 5 to both sides. We get 11 and divide by 6. So to solve such a system of equations, we're required to find x, y, and z. X, y, and z. For each function below, do the following: graph, find the intercepts, domain, range, let's try this one. So how are we going to graph this? The easiest way is to form a table of values. So we have x and get the corresponding y values. Just a point, I don't know if you remember from class, it's a small trick. Set this equal to 0, you get x equals 2. That 2 goes in the middle of the table. And then pick the next value and the next value, 3 and 4. And the lower value and the next one. This is the best way to choose the most convenient values for x. If you substitute 0 in there, it's gonna look like this, which is 1 over 3 squared, 1 over 9. If you substitute the 1 in, 1/3. If you substitute the 2 in, it's 1. If you substitute the 3 in, it's a 3. If you substitute 4 in, you're gonna get 9. When you graph, label the x and the y with the arrows and the origin. 0, 1, 9, so let's say 1, 2, 3, 4, 5. 0, 1, 9, so that's the first value. 1 and 1/3, a little bit higher. 2 and 1. 3, 3. 4, 9, somewhere, I don't know, maybe up here. So it goes like this. It's an exponential function. As you can see, the y-intercept is this point. So y-intercept at 0, 1, 9. X-intercept is none. X-intercept is none. Domain is all real numbers. Range 0 to infinity. So we have, this is a parabola. Yes, those will be online, so if you can't copy, it's okay. So here, this looks like x minus h squared plus k. So from here, if you compare them, h is -2. Compare these two, k is -4. So we have a vertex -2, -4. Vertex is the key to solve to graph such a function. As soon as you get the vertex, this is how you get the table of values. This x value from the vertex goes in the middle of the table. On the number line, what comes to the right of -2 is -1, then 0, -3, -4. This one we found the y value -4. Now, probably it's easier to substitute the ones on the right side. Like if you substitute x equals -1, what do you get? -1 plus 2 square minus 4. 1 square minus 4. 1 minus 4, -3. Substitute 0. That's 4 minus 4, 0. If you follow this strategy of choosing the x values, it makes things easier because by symmetry these two must be the same and these two values must be the same. So I don't have to substitute them again. So we are ready now to graph it. 0, 0, -1, -3, -2, -4, -3, -3, -4, 0. What a nice graph sketch. For the y-intercept, 0, 0. For x-intercept, we have 0, 0 and also -4, 0. That's where the graph crosses the x-axis. For domain, what's the domain for this? Is all real numbers. The range, if you start from the bottom up, you first get across -4 all the way to infinity. Or you can say y bigger than or equal to -4. Either way would be fine. How to solve reviewed solving inequalities. First one, absolute value inequalities. And number 2, let's do the first one. To solve inequalities in this form, like absolute value and less, so the easiest way is that 2x plus 5 less than 9 bigger than -9. We need to get x in the middle, so to do so you subtract 5 on all of them. -14 less than 2x less than 4. One final step, divide everything by 2. -7 less than x less than 2. It's solved. So the interval notation for this would be -7, 2 because it's only less than. Now to solve the next inequality, what we do, we subtract first 1 over x plus 1 from both sides. We cannot cross multiply, we cannot multiply by anything. Then the common denominator here is x minus 4, x plus 1. Do not cross multiply. So here what we need x plus 1. We do the same thing on the top. We need x minus 4. We do the same thing on the bottom. 1 times x plus 1 minus 1 times x minus 4. Keep the denominator the same. On the top you get 1x plus 1 minus x plus 4. So these cancel out. That will leave 5 on the top, which is not going to make a difference. And the denominator stays the same. Now we are going to finish solving this on the number line. Using number line, we have a negative 1 if you set this equal to 0, and 4 if you set this one equal to 0. Now we pick points, select values like 5. Let's say x equals 5. What would give this positive or negative value? Well, it's positive value, right? If you pick something between negative 1 and 4, maybe 0 or 1, that will give me negative, and then positive. The question is asking, when is it positive? Well, it's positive from negative infinity to negative 1, union 4 to infinity. Next, how do we sketch a graph for a system of inequalities? So how do we solve? To do that, we start with the first one, 2x minus 6y. Make it equality here, like so. Why do we make it equality? Because it's easier. We need to graph it first. You set x 0, you get negative 6y is 6, y is negative 1. So 0, negative 1. If you set y 0, you get 2x equals 6, x equals 3. So 3 comma 0. So I'm going to graph it here. Plot these 2 points. 0, negative 1. 0, negative 1. 3, 0. So we draw a solid line because it's all equal. And now we have to do shading. The shading part, let's see. 2x minus 6y bigger than or equal to 6. So what we need to do is to select a testing point, maybe 0, 0 as a testing point. Substitute that in here. You got 2 times 0 minus 6 times 0. Is that going to be bigger than or equal to 6? 0 minus 0 bigger than or equal to 6. That's false. So the region containing the origin is a false region. So we have to shade this one, not the one that contains the origin. That's the first one. We do the same for the second one. So we are going to look at the second inequality. X plus y less than or equal to 1. So make it x plus y equals 1 for easy to graph. When x is 0, y 1. So I got a point 0, 1. When y 0, x is 1. So I get 1, 0. So 0, 1, 1, 0. 0, 1. 1, 0. Again, another solid line because it was or equal. We can pick the origin as the testing point again. Substitute in here. We got 0 plus 0 less than or equal to 1. This is true. Since it's true, that point 0, 0 contains is the true region. So I'm going to shade this region because this is the one that contains the origin. And both of them, they overlap here. So that's the solution region. Let an be negative 1 to the n plus 1 over n factorial. List the first 3 terms of this sequence. We don't know what n is, but if n is not specified, this means n is bigger than or equal to 1. So you can take n equals 1. We get a sub 1 by substituting 1. So negative 1 to the 1 plus 1, 1 factorial. Negative 1 square over 1. That's a positive 1. N equals 2. A sub 2 is negative 1 to the 2 plus 1 over 2 factorial. Negative 1 to the third over 2. Negative 1 half. N equals 3. A sub 3. Negative 1 to the 3 plus 1. So these are the first 3 terms, 1, negative 1 half, and 1 6. How do we write the given series using sigma notation or summation notation. Two plus 2 over 3, 2 over 5, okay, so what do you see in here? We have 2 on the top, so we need to find the sigma notation. There's always 2 on the top. In the denominator, the numbers are 1, 3, 5, 7. Those are odd numbers. Any odd number can be written in the form 2n plus 1. Any even number can be written in the form 2n. Three factorial, back to this, is 6 because 3 factorial is 3 times 2 times 1. If you happen to find 5 factorial, you just take 5 multiplied by all the numbers until you reach 1. So if I want to put 2n plus 1 here, you know, some people write 2n plus 1 or 2n minus 1, depending on what you want to get to. Now, n, we need to always make sure n is 1, starts at 1. And the 3 dots means it's an infinite. So we put infinity there. Now, if we need to test it out, if n is 1, plug n1 here. 2 over 2 times 1 plus 1. That's 2 over 3. Oh, that doesn't give me the first one. So in this case, we try to put the minus 1. Test it now. It works. If you substitute the 2 in, you get the next one. 3 in, get next, and next one. So it works. What about if I change the same one into and make it alternate, plus minus plus minus? I still see 2 on the top, and I still see the same thing in the denominator. N equals 1 to infinity. What changes here? We have the alternation in the signs. The alternation in the signs, we always use -1 to the n or -1 to the n plus 1. One of them must work. If you try -1 to the n, when you substitute the 1 in, let's see what we get. We get 2 times -1 to the first, 2 times 1 minus 1. -2 over 2 minus 1. -2 over 1. And that's what the first term is. So it worked out. If it doesn't work out, you replace the -1 to the n with -1 to the n plus 1. Any questions about this? Recall x minus h squared plus y minus k squared equals r squared is the equation of a circle. Center HK, radius R. So if I give you not the best graph, find the equation of the figure to the right. Always, you know, this is going to be a circle. To find the equation of circle, two things are needed. One is the center and two is the radius. So if you look at these numbers they give us here, this point is 1, 2. This point is 5, 2. 3, 0. 3, 4. So what would be the midpoint? At 3, 2. So the center is 3, 2. This is h and k. And the radius is what? Is the distance from here to here, or here to here, or here to here, or here to here. That's the radius, which is 2 units. Now we know the formula. X minus h squared plus y minus k squared equals r squared. X minus h is 3. Y is 2. R is 2. That gives us x minus 3 squared, y minus 2 squared equals 4. Ellipses. If the ellipse goes this way, it has equation x squared over a squared plus y squared over b squared equals 1. Remember, a always bigger than b. What is a? This is the center here. A is this distance from here to here, or this distance. This is B. This is B. Now, if the ellipse goes this way, then this is A, B, B. The equation is x squared over b squared, y squared over a squared. Again, A always bigger than B. See, A below the y here. Find the equation of each ellipse. Let's look at this one. It's horizontally, so it's x squared over a squared. A here is this, which is 3 units. B is this, which is 1 unit. So that gives us x squared over 9 plus y squared over 1 equals 1. For this one, this is A, this is B. So A is 4 and B is 2. So it goes x squared over 2 squared, y squared over a squared. So the bigger number goes below the y. Here the bigger number goes below x because it's parallel to the x-axis. The second one was parallel to the y-axis. So the bigger number goes below the y-axis. Any questions for me? (16) is the 4 square. This is a square, this is b square. Other questions about anything else? Now the last thing I want to talk about is the grading. So to check how your grades, what you have so far, you can take exam 1 plus exam 2 plus exam 3 plus exam 4 plus all the homework assignments, plus you can estimate the extra credit if you submit that and get the total. And then you go back to the syllabus and see, it will show you how many points minimum you need to get an A or B or C. See how many more points you need on the final to get the A or B or C. So I think the final is worth 200 points. So you will know before you start the final how many points you actually need. So if someone needs to get an A and need 205 points, so that would be impossible. But it's easy to get the B.